When you delete, you'll be prompted with things like this. Do you want to remove the reference, which means keep the file, just get it out of this project, or actually delete the file. In this case, I don't really care, so I'll ditch it altogether. Now over here, a PCH file. So the comment atop this kind of explains what it is. A PCH file is a precompiled header. You will rarely, if ever, need to touch these. Think of this as a file that's automatically prepended to all of your files. And in this case, you're sort of automatically getting access to the foundation class, even if you don't explicitly specify it, but you can put more stuff there. So this is one of those files that it exists. You don't really need to worry about it, but don't delete it because the compiler will then choke because it expects that it exists. Foundation framework. So these are just all of the header files in the foundation framework, so to speak. All of these you get access to by way of the import statement that we saw before. These are not actually all copied into your program per se. It's simply here so that you can browse them if you want. But frankly, it's typically easier to look at the documentation online. But if we do scroll down here, we should see some things that are familiar, like NSString. And indeed, there is someone's declaration of everything related to this thing we called an NSString. And if this looks overwhelming, don't worry. C looks exactly like this underneath the hood. It's there if you need it, but the documentation on the web is much more user-friendly. And lastly, there's this. And what is this? It's the binary. It's a.out, but with a sexier name. And so if we go ahead and double-click that or click the Run button, voila, we have our first Objective-C program up and running. So new environments, slightly new syntax, some of which we're just going to close our eyes to for now. Let's go ahead and take a 5-minute break, and we'll resume with more interesting Objective-C apps. All right, we are back. Any questions on Hello World? Or anything we've discussed thus far? Yes?
What is the NS stand?
Next step. Good. Any other review? Go ahead. All right? Yeah?
Well, for the @ symbol, I know it was used to precede the string to tell it that it's an NS.
Mm-hmm.
But it was also used like on auto release pool. Does that just have like a general tell compiler to do something, or is it more different?
Good question. The @ we've seen before strings now, and we've also seen it before auto release pool. I believe it's been used by Apple to implement new functionality because it does not collide with any existing use of a symbol. So it means very different things in those contexts, and those are the two primary ones we'll see it in. But it's not some special, it doesn't have some overarching meaning other than it was available. All right. So in terms of bootstrapping yourself and learning this stuff and mastering this stuff ultimately, besides the books, realize there's a huge amount of material online, and certainly buying a book is not prerequisite. The entry point to most of Apple's software development resources are all at that URL here. You can always just Google iOS SDK, and this will lead you to this particular website. Realize a couple of things. It's fine to log in, and you can create an account using your existing Apple ID, which you use with your iPhone or iTunes or the like, or just sign up for one for free if you want. You do not have to pay the $99 or $199 to become a certified Apple developer. What that typically provides you with access to is Xcode and older versions of it, and Snow Leopard compatible versions of it, for instance. It also allows you to install software that you write onto your own phone. As I think I mentioned in the first lecture, Apple has this funny way of making you pay them to install software on the phone you already own, because you essentially need the right kind of encryption keys and the like to do this. However, because we're a class, we do have an academic account, so that so long as you guys provide us with your unique identifiers for your devices, and we'll get to this in a couple weeks with Project 2, you can install software that you write on your phone for free. The one constraint is you can't then add that software to the App Store. So if you decide at the end of the semester or mid-semester that you want to try selling or giving your app away for free on the App Store, that's totally fine. You own the software, not the course, but at that point you'll have to pay at least the $99 fee in order to do so. So just realize that. In terms of finding stuff here, this is frankly where I think things get overwhelming. I never really learned this stuff well by navigating Apple's website. There is a lot of sample code. There's a lot of tutorials, but they're sort of, at least for my brain, all over the place. So to be honest, Google is your friend. So like if you look up NSString reference, you will then dive deeply right into the documentation, which generally looks like this. So it's actually quite good. Once you get to what you're looking for, like something like this, it's actually modeled similar in spirit to like PHP.NET, whose documentation I think in general is great. Similar in spirit to a man page, but a little certainly more web-friendly. So what you'll see here in the NSString class, and we'll tease apart some of the syntax here soon. You see what its parent class, if any, is. If you're coming from the world of Java from high school, recall that there's the object superclass from which everything descends. So there's some hierarchy built in automatically to Objective-C. Notice that there's these protocols here, conforms to these various things, but we'll talk briefly about those this week and next, and we'll see them more over time. And then there's just links to related resources. And then if we start scrolling down, the overview is generally helpful if you want to understand what the class is. Let me keep scrolling, and here we go. For some reason, they call these things tasks, but they really are just methods, although you'll also see people refer to them as messages, which has a slightly different semantic meaning, but refers to the same kind of thing. And believe it or not, these are all of the various methods that are associated with the string class. So if you thought of all of our getters and setters were a lot earlier, well, welcome to the NSString class. Now, frankly, this is the sort of thing where odds are you won't need most of these, and you probably shouldn't care that most of these exist. But much like PHP, which tends to have the kitchen sink of methods and functions, so does Objective-C have a huge amount of functionality built in, for better or for worse. So typically Googling around, consulting Stack Overflow, consulting a book, or just reading through the documentation should often be your first approach to figuring out whether some function or method exists. So as for these minus signs and plus signs, which we saw briefly up here, these actually have special meaning, which we'll get to in just a moment. All right, so data types. So Objective-C supports C. It's a superset again, which means you get char and float and long and all of these, but you also get some additional data types. Among them these, bool in all caps, which unfortunately, given the language's history, the value of a bool is not true or false. It's not 1 or 0. It's instead literally yes or no in all caps in both cases. So just one of those things you get used to. ID is actually similar in spirit to a void star pointer, which we don't talk about in 50 really. You might have seen it in CS61. A void star pointer is just a pointer that can point to anything, an int, an object, or the like. It's a way of very weakly typing some variable in C and treating it however you see fit, or coming up with very generic data structures that store pointers to void objects, anything. ID has a little more functionality built in that it's similar in spirit to a void star, that you can have an ID variable point to anything, but we'll see that it has special meaning when it comes to something called nil and being passed messages. So this is a useful object-oriented thing. Nil is like null, but we'll see that whereas in C, dereferencing null, calling a method on, let's see, yeah, in C, dereferencing null generally did what? Segfault, very bad, right? So dereferencing null or garbage pointers is a very bad thing. Objective-C is much more forgiving. If you accidentally or knowingly try to call a method on a null object, now called a nil object, nothing bad will happen. It will just silently ignore the method call on it. So this is a good thing. It can still mask errors if you didn't quite intend to do that, but it can also avoid a huge number of bugs and problems in your code. So we'll see that as a feature and how to leverage that. So in terms of other data types that you don't get with Objective-C per se, but you do get with the foundation library, and recall that this library is akin to standard lib.ih, standard io.h from C, but you just get more stuff in foundation.h and its various files. You get things like nsinteger, nspoint, nsrect, nssize, nsunsigned integer. The only point of confusion here is that even though these things are capitalized with ns, they are not in fact objects, like NSString actually is, as we saw from its documentation. These are type defs, which if you recall from C, allows you to make one word a synonym for another. And so we did this in like pset5 and CS50 where we had a byte. Well, we actually type def that to like an unsigned char, 8 bits. Same deal here. So an NS integer is essentially an int underneath the hood, and an NSU integer is an unsigned int. This is just Apple's way of providing an abstraction layer so that in theory, theory, they could change the underlying implementation of these data types, even though in practice they're not likely to change. But just realize they're not objects. They are primitives, and it's just a syntactic potential for confusion. All right, here we go. Here comes the fun syntax. So in PHP, we don't have the notion of a header file, right? We pretty much just put everything in .php files. We can isolate classes to their own PHP files and methods and controllers and models to their own files, but there isn't this sort of dual existence of two types of files in PHP, or most languages for that, or in many languages for that matter. But in C and in Objective-C, we have it. So in Objective-C, typically, if you want to declare some class, like we did at the very start of today in PHP. If you want to declare a class in Objective-C, you put that declaration of the class in a header file, in a .h file. And the syntax you use is this: at interface, the name of the class you want to declare, in this case it's foo, colon, the name of the class that it descends from, if any. Because we're using Objective-C, it will almost always descend from NSObject or something else, so that you at least get some base functionality from the entire framework. Open curly brace, close curly brace. And inside those curly braces, as the comment here suggests, that's where you put your instance variables. Things like a student's name, things like a student's year, and any of that kind of data that you want to encapsulate inside of this object. So points of confusion here. This is a class, but it's at interface. PHP has interfaces. C++ or Java has interfaces. Objective-C has interfaces, but they're really classes. Okay, so at interface is a class. It's just different jargon for the same idea. What Objective-C calls protocols are equivalent to PHP and Java's interfaces. Okay. Just Google it when you're confused. All right, so now, and this is a bit of the syntactic messiness, when you actually want to declare the methods that are associated with this class, you actually put it outside of the curly braces, but before the symbol at end. So this is just one of the things that rubbed me the wrong way the first time. You get used to it, and everything looks beautiful eventually. But for now, just realize there isn't quite the beauty of PHP or Java that encapsulate everything that's related with big curly braces. In this case, the method declarations will actually be outside of the curly braces, but before the at end symbol. So just realize you just kind of have to get used to it. All right, and now the .m file. In the .m file, it's actually a little more straightforward. At the top of the file or thereabouts, you would say at implementation, the name of the class that you're implementing. That's it. You don't have to mention the parent class with a colon or anything like that. Then where the comment is, you put your definitions of methods, you implement them, and then at end at the very bottom. And in theory, you can put multiple classes in the same file, but generally we'll segregate things to separate files, as we've been doing for student classes and course objects and the like. All right, checkpoint. Any questions thus far? All right. So, instance variable. So what is an instance variable? Not necessarily in the context of Objective-C, but in general. What's an instance variable? Yeah?
A variable that will belong to like a specific instance of a class. So like,
perfect.
Let's say you make a new person, it will have its own name.
Perfect. So it is a variable that belongs to a specific instance, aka object, of some class. So we did this in PHP earlier. We had a student class, and inside of a student class are two instance variables, name and year. And they're instance variables in the sense that you can only set those once the class actually exists. This is in contrast to something called a class variable, which is shared by all members of that class. And just to put this into that same context, if more familiar, let me go ahead and just pull up a quick text editor. So earlier when I said class student, and then I had public, we'll go back to version 1, public year. If I now did, let's say, static, actually, can I do this in PHP? Yes. Yes. All right, thank you. You were my Google. If I say static foo, in PHP, the syntax for saying that you want a class variable is to say that it's static. So it's not public or private. It's actually public by default, but static, which means that all objects that are instantiated from this class will have that same value of foo. And in fact, you don't even need to instantiate an object of type student in order to access that foo variable. So it's kind of like a class constant, but it's not necessarily constant. It can be mutated or defined by you. a priori. So that's all we mean by that. So instance variables are essentially the types of variables we've been talking about all this time. Just as in PHP, you can specify things like private and public or protected, where they generally mean what's familiar to you, and protected is essentially somewhere in between public and private. But we'll see these more over time. So class method. What is a class method? Well, just like a class variable is one that exists inside of a class, even if you've not instantiated any objects. And when you do, it's shared by all of those objects of that class. A class method is one that you can call on a class without having to instantiate an object in advance. You can just call it. So you can think of a constructor as effectively being a class method in the context of, say, PHP, or some other languages, where you can call it explicitly before you have an object